Hey guys, in this video I'm going to go over questions 15, 16, and 17 from the 2016 AMC 12A. This is question number 15 and it reads circles with center P, Q, and R having radii 1, 2, and 3 lie on the same side of line L and are tangent to L at P prime, Q prime, and R prime respectively, with Q prime being between P prime and R prime. The circle with center Q is externally tangent to each of the other circles. What is the area of triangle PQR? So a common misconception a lot of people are going to have when they solve this problem is they're going to think that PQR are all collinear. And the reason that that's incorrect is for those points to be collinear, the slope from P to Q has to equal the slope from Q to R. And since slope is rise over run, we know that the rise from P to Q is 1, and the rise from Q to R is also 1. However, the runs are going to be different because the run from P to Q is going to be less than the run from Q to R. And that's going to mean that the slope from P to Q is larger than the slope from Q to R. So our triangle is going to look something like this. So how we're going to find the area is we're going to first take the area of pentagon P, P prime, R, Q, and subtract from that the area of P, P prime, R. So in order to find the area of the pentagon, we're going to split it into two pieces, right? We're going to split it into trapezoid Q, Q prime, R, and trapezoid P, P prime, Q. And how we're going to find the area of a trapezoid is we're going to first have to find the altitude, right? So we can drop an altitude from Q to this side. And this distance right here is going to be 3 minus 2, which is 1. And using the Pythagorean theorem, we can find that this altitude is going to be 5 squared minus 1 squared, square root of 24, which is 2 root 6. So this value is going to be 2 root 6. And next we're going to be able to find the area here. The area is just going to be 2 plus 3 over 2 times 2 root 6. And this is going to be 5 root 6. And now we can do the exact same thing for this trapezoid right here. If we drop the altitude, this distance is going to be 1. And we can use the Pythagorean theorem again. It's going to be square root of 3 squared minus 1 squared, which is root 8. And it's going to be 2 root 2. So this altitude right here is going to be 2 root 2. And if we find the area of this, we're going to have 1 plus 2 over 2 times 2 root 2, which is 3 root 2. So the area of this pentagon right here is going to be 5 root 6 plus 3 root 2. So the area of the pentagon is 5 root 6 plus 3 root 2. And next, I'm going to clear some space real fast, but the next thing we're going to do is find the area of this large trapezoid right here and subtract it from this value. And what's going to be left is the area of PQR. So with a large trapezoid, the height is just going to be 2 root 2 plus 2 root 6, right? And then we're going to multiply that by 3 plus 1 over 2. The 2's cancel, so we're going to have 4 root 2 plus 4 root 6. So 5 root 6 plus 3 root 2 minus 4 root 2 minus 4 root 6 is going to give us square root of 6 minus the square root of 2, and that's going to be D. So this is question number 16. It reads the graphs of y equals log base 3 of x, y equals log base x of 3, log base 1/3 of x, and log base x of 1/3 are plotted on the same set of axes, how many different points in the plane, with positive x coordinates lie on 2 or more of the graphs. So what we're going to do to solve this problem is find every single possible pair of these equations and set them equal to each other to see if they produce any new solutions. So first we can pair these two equations. So we have log base 3 of x equals log base x of 3. If we use change of base on the right side, we're going to get log base 3 of x equals log base 3 of 3 over log base 3 of x. And if we multiply log base 3 of x on both sides, we're going to get log base 3 of x squared equals log base 3 of 3, which is just 1. So we know that log base 3 of x can be 1 or negative 1. If it's 1, then x is going to be equal to 3, right? And if we plug in 3 to y, we're going to get y equals 1. And if x is negative 1, or if log base 3 of x is negative 1, x is going to be 1/3, and y is going to be negative 1. So these are the two solutions we get for equating the first and second equation. We can write them up here. 3, 1, 1/3, negative 1. And we're going to keep this just in case we find any solutions that are the same as these, because then we don't want to be overcounting, right? So next we're going to equate these two. We're going to say log base 3 of x equals log base 1/3 of x. If we use change of base again, we're going to get log base 3 of x equals log base 3 of x over log base 3 of 1/3. Log base 3 of 1/3 is going to be negative 1. So we're going to have log base 3 of x equals negative log base 3 of x. And the only way this is possible is if log base 3 of x is 0. So log base 3 of x equals 0, x equals 1. And if we plug in 1 to the first equation, y is going to be equal to 0. So we're going to have 1, 0 as one of our solutions. So next we're going to equate the first equation and the last equation. We're going to have log base 3 of x equals log base x of 1/3. If we use change of base again, we're going to have log base 3 of x equals log base 3 of 1/3 over log base 3 of x. And if we multiply log base 3 of x on both sides, we can get log base 3 of x squared equals negative 1. But this is impossible because if we take the square root of both sides, we're going to get I on the right side. So we're not going to find any real solutions here. So next we're going to take the second equation and the third equation. We're going to say log base x of 3 equals log base 1/3 of x. If we use change of base again, we're going to get log base 1/3, or actually let's do it the other way around. I think it's easier. If we have log base x of 3 equals log base x of x over log base x of 1/3. Log base x of x is 1, so we're going to have log base x of 3 times log base x of 1/3 is equal to 1. And wait, actually I think we should have done it the other way around. So if we have a log base x of 3 equals log base 1/3 of x, we're going to have log base 1/3 of 3 over log base 1/3 of x equals log base 1/3 of x. So if we have log base 1/3 of x squared, it's going to be equal to negative 1. And again, this is going to produce an imaginary number or a complex number, and we're not going to find any real solutions here. So next we're going to take the third equation and the fourth equation, and we're going to say log base 1/3 of x equals log base x of 1/3. Using change of base again, we're going to have log base x of x over log base x of 1/3 is equal to log base x of 1/3. So log base x of 1/3 squared is going to be 1. And again, we're going to get two solutions, negative 1 and 1 for log base x of 1/3. 1 or negative 1. If it's 1, then x is going to be 1/3 and y is going to be 1. So, and that's the new solution, so we can write it down here. And if this value is negative 1, then we're going to get x to the negative 1 equals 1/3. So x has to be equal to 3. And if x is 3, then y is going to be negative 1. And that's also a new solution. So in total, we're going to have 5 solutions, and answer is D. So this is question number 17. It says, let ABCD be a square, let E, F, G, and H be the centers, respectively, of equilateral triangles with bases A, B, B, C, C, D, and D, A, each exterior to the square. What is the ratio of the area of square AFGH to the area of square ABCD? So the first thing you have to do is to draw a square ABCD. And since we're just being asked for the ratios, and not for the actual areas, we can just set each side length equal to 1, since it's a lot more convenient. So we have equilateral triangles with bases AB, BC, CD, and DA. And we have centers E, F, G, and H. They also make up a square. So when they say the center of a triangle, they're talking about the centroid, right? Which is the intersection of the medians. And one property of the centroid is that the distance between the centroid and the base is going to be equal to 1/3 of the triangle's altitude. And since this triangle has side lengths 1, it's really easy to find the altitude using the Pythagorean theorem. And so the altitude is going to be the square root of 1 squared minus 1/2 squared, which is going to be the square root of 3/4, which is going to be √3/2. And since the distance from E to the base is going to be 1/3 of that, we're going to have √3/2 times 1/3, which is √3/6. Since we're trying to find this diagonal of square EFGH, this diagonal is going to have length 1 plus 2 times √3/6, which is going to be 1 plus √3/3. And this is going to simplify to 3 plus √3/3. And since the ratio between the diagonal of a square to a side length is square root of 2, if we divide this by the square root of 2, we're going to get this value, which is going to be the side length of square EFGH. And if we square that, we're going to get the area. And if we simplify this, we're going to get 9 plus 6√3 plus 3/18, which is going to be 12 plus 6√3/18, which simplifies to 2 plus √3/3. Since we're trying to find the ratio between this and the area of ABCD, which is 1, the answer is just going to be 2 plus √3/3, which is B.